Hi everyone, Professor Bob Young, and in this instructional video we're going to discuss rationalizing the denominator and rationalizing the numerator. Now, when we talk about the concept of rationalizing the denominator, this removes all radicals from the denominator of a fraction. And always remember to simplify all radicals first. Now, in these first several examples here on this graphic, all the radicals are simplified, so I just want to get some basic concepts through so you understand the process here. So in the first example, 3 over the square root of 5, if I want to get this radical out of the denominator, I'm going to have on a square root, remember, the root number, there's a little 2 in here, although they don't write it. And this 5 is to the first power. So what we're going to do is multiply both top and bottom of this fraction by that same square root. Now what that does for us, the top, we have a number times a radical, and that's how you write it, 3 times the square root of 5. If you watched that last video on multiplying radicals and so forth, you can multiply numbers with numbers and roots with roots, as we said. The bottom, when you multiply the square root of 5 times the square root of 5, whenever you multiply same bases, power rule number 1, you add the exponents, and you get the square root of 5 squared, so the 5 comes out of the radical. Another way to look at it, the square root of 5 times the square root of 5 is the square root of 25, and you get a friendly square root. But either way, we have accomplished our goal. We have gotten the bottom number to be a number, which is called a rational number, by the way. 5 is a rational number because you can make it a fraction, 5 over 1. See, so what we started out with, the square root of 5 over here, is an irrational number, and if you put that in your calculator, you would get this number that runs off the screen, and it keeps going forever and ever. So what it does is it just takes the radical out, almost like Visine takes the red out, that old Visine commercial. We're taking the radical out of the bottom. Next example, 5 over the cube root of x. Now notice there's 1x under this second radical, and we need to get out from under a cube root, so we need to force 3 of everything here. So I'm going to multiply this by the cube root of not just x, but x squared. Now, I know what some of you are saying, Young, why did you do that? And whatever you do to the bottom of a fraction, you must do to the top. So be careful. These are fractions. Well, why I did it, to answer your question, not that anyone ever asked one there, you might have thought about it. Say, stop it, Young. Is you're trying to force 3 of the same thing under a cube root in order for it to come out. So remember those fractional exponent videos that you watched earlier on, the old E over R, you're going to get, if you wrote that in fractional form, x raised to the 3 over 3 power, which would just be x, and again on the top, multiply numbers with numbers and roots with roots, and that is rationalizing that one. So really, ladies and gentlemen, looking at this third example, this root number right here tells you how many things under here, the radicand, that you need to force to get out of that radical in the bottom. So if we've got the 4th root on this third example, we are going to multiply by the 4th root of how many more a's do we need to get 4? Think about this. We need 2 more because we got 2 under there. How many more b's? 1. I hope you're seeing it out there. C's, we got 1 under here. You can put the 1 if you don't have a power. We need 3 more. And remember, whatever you do to the bottom, do to the top. So this example will come out, and notice when we do this here, we are going to, when we multiply the 4th root times the 4th root, roots with roots, we get the 4th root of A4, B4, C4, which comes out A, B, C, as easy as do, re, mi, as easy as 1, 2, 3, A, B, C. It's that old Michael Jackson song from when he was little. Say, Young, keep your day job. All right, and there is the final answer there. And finally, I thought I'd throw some numbers in here and some variables on this fifth root. Now notice this 4 here under the radical, you can prime it. So on this one, I threw a little bit different twist. And on a fifth root of a fraction like this, remember, using the quotient rule, you can break this up into 2 little fifth roots. So I'm going to go ahead and prime that 4 and make it 2 squared, a to the first, over the fifth root of 3 to the first, b to the first. So ladies and gentlemen, if you have been paying attention out there, we know to get out from underneath this fifth root, we need to force, guess what, 5 of everything in the denominator to rationalize it or get rid of that radical in the bottom. So we are going to multiply both top and bottom by the fifth root of what? Over the fifth root of what? We need how many more 3's in that denominator? We need 4 more 3's, and we need 4 more b's, and whatever you do to the bottom, do to the top. So the bottom will come out the fifth root, and I'll bring that up here. I'm going to bring it back up high here, so I don't want to run off the screen on the video. I have done that on a few videos, so I'm trying to avoid that. So the fifth root of, some of you do this when you do your homework papers, I know. The top would be 2 squared times 3 to the fourth with 1a and 4 b's under there. And the bottom would be the fifth root of 3 to the fourth, b to the fourth. Or I'm sorry, 3 to the fifth. 4 and 1's 5. I'm still waking up here drinking my coffee doing this video. B to the 5. You never know what I'm doing when I'm doing these videos here. Now notice I know the top, and I'm going to get some colors going here, is rationalized here. Okay, I know that's rationalized because all of those exponents under the radical are less than 5. And we've talked about that in previous lessons, all right? And we know that these are going to be doing the E over R rule coming out. So we're going to end up with 3 to the first, b to the first. 5 goes into 5 once. Now on the top up here, they're not going to leave 2 squared times 3 to the fourth. They're going to go ahead and make that 2 squared 4, and that 3 to the fourth, 81. And 81 times 4 is going to give us the fifth root of 324, a, b to the 4. So make sure you put all your numbers together once you get it done. All right, so I'm going to go ahead and break these videos up a little bit here. So I'm going to call this one done, and we will come back with more rationalizing the denominators and numerators in the next several videos. This is Professor Bob Young signing off. Start pounding on that homework and do well.